Pluto might have lost its status as a planet, but it remains a fascinating celestial object for scientists who now have a powerful tool to study it, the James Webb Space Telescope. Thanks to this new generation space observatory, scientists are making astounding discoveries, and what they've found on Pluto is nothing but mind-boggling. What have scientists found on Pluto? How does it affect you here on Earth? And can these new discoveries make Pluto qualify as a planet again? Join us in this video as we dive into the James Webb Space Telescope's terrifying discovery on Pluto that changes everything. Where do we start talking about Pluto? It is a complex and mysterious world with mountains, valleys, plains, craters, and maybe glaciers. Pluto is only about 1,400 miles wide, making it only about half the width of the United States. In practical terms, if Earth was the size of a nickel, Pluto would be as big as a popcorn kernel. Even though Pluto is far away, scientists are getting ready to tease out more of the secrets hidden away on the dwarf planet thanks to the new James Webb Space Telescope. Pluto is an average distance of 3.7 billion miles or 5.9 billion kilometers from the Sun, or about 39 astronomical units away from the Sun. Sunlight takes about 5.5 hours to travel from the Sun to Pluto. What if you find yourself on Pluto? Chances are you won't like it. If you were to stand on the surface of Pluto at noon, the Sun would be 1/900th of the brightness it is here on Earth, or about 300 times as bright as our full moon. In fact, there is a moment each day near sunset here on Earth when the light is the same brightness as midday on Pluto. There is also the temperature. The average temperature on Pluto is minus 387 degrees Fahrenheit, or minus 232 degrees Celsius. Pluto has a 248-year-long rotation around the Sun. The oval-shaped orbit can take it as far as 49.3 astronomical units AU from the Sun and as close as 30 AU. For example, between 1979 and 1999, Pluto was near perihelion when it is closest to the Sun. During this time, Pluto was even closer to the Sun than Neptune. One Pluto day takes about 153 Earth hours. Its axis of rotation is tilted 57 degrees with respect to the plane of its orbit around the Sun, so it spins almost on its side. Pluto has the distinction of being named by an 11-year-old girl, Venetia Burney. Burney suggested the name to her grandfather, who forwarded it to the Lowell Observatory Institute where Pluto was discovered. Despite its smaller size and being demoted from being a planet, Pluto has 5 known moons: Charon, Nix, Hydra, Kerberos, and Styx. Scientists theorize that Pluto's moon system was formed through a collision between Pluto and another similar-sized body in the early days of the solar system. Charon is the biggest of Pluto's moons and measures about half the size of Pluto. In fact, the size ratio is the most ridiculous in the solar system. Charon orbits Pluto at a distance of just 12,200 miles, or 19,640 kilometers. Our moon is 20 times farther away from Earth. In fact, Pluto and Charon are sometimes referred to as double planets. Charon's orbit around Pluto takes 153 hours, exactly the same time it takes Pluto itself to complete one rotation. So on Pluto, you will always see the same side of Charon. This is known as tidal locking. The other moons orbiting Pluto are much smaller, as moons should be. They are less than 100 miles or 160 kilometers wide. They're different from Charon because they are irregularly shaped, not spherical like Charon. Unlike many other moons in the solar system, these moons are not tidally locked to Pluto. They all spin and don't keep the same face towards Pluto. Pluto has a varied topography. You will find mountains, valleys, plains, and craters. The tallest mountains are 6,500 to 9,800 feet, or 2 to 3 kilometers in height. However, these mountains are not composed of rocks or dirt. They are massive blocks of water ice that are sometimes coated with frozen gases like methane. Pluto also has long troughs and valleys as long as 370 miles or 600 kilometers. Pluto boasts of craters too, and some are up to 162 miles or 260 kilometers in diameter, with some showing signs of erosion and filling. This suggests to scientists that tectonic forces are slowly resurfacing Pluto. The most prominent plains observed on Pluto appear to be made of frozen nitrogen gas and show no craters. These plains do show structures suggesting convection or blobs of material circulating up and down. Just like the Earth, Pluto has an atmosphere, but with a twist. The atmosphere is thin and expands on getting closer to the Sun. As Pluto moves farther away from the Sun, the atmosphere collapses. The main constituent of the atmosphere is molecular nitrogen, but scientists have detected molecules of methane and carbon monoxide too. When Pluto is close to the Sun, its surface ices sublimate or change directly from solid to gas and rise to temporarily form a thin atmosphere. Pluto has a low gravity, which is about 6% of Earth's, and causes the atmosphere to be much more extended in altitude than our planet's atmosphere. Pluto becomes much colder during the part of each year when it's traveling far away from the Sun. During this time, the bulk of the planet's atmosphere may freeze and fall as snow to the surface. Pluto has its own series of amazing features that remain yet unexplored. A prime example is the Tombau Regio, the unofficial name given to the heart-shaped region observed on the surface of Pluto. A part of its landform is likened to an ice cream cone shape but is strictly covered by carbon monoxide ice. It's now iconically identified as the heart of Pluto. Right in the middle of the heart-shaped crater is another smooth region named Sputnik Planum by the probe's team, a name it now shares with Earth's first artificial satellite. Meteorite impacts are known causes of craters in most planetary bodies, but the Sputnik Planum doesn't have such a deformation. According to the geological timescale, scientists deduced that it is a relatively young region and could be about 100 million years old. There are suggestions that it might be yet to attain its permanent shape, as geological processes can continually change it. Much like the kind of streaks you can often see in Earth's arid region, the scientists observed a series of dark streaks that appear to be a few miles long and going in the same direction on the surface of Pluto's icy plains. What could have caused this? Could it be the not-so-friendly winds that frequently blow across the planet's surface? Also, the dunes on Pluto are only one of the planet's many surprises. On Pluto, the dunes are not composed of sand like that of Earth, but of solid methane ice grains that are molded by the wind. Dunes are more common than you might expect in our solar system. They exist solely on Earth, Mars, Venus, Saturn's moon, Titan, and comet 67P. Due to the fact that these dunes are mostly undisturbed on Pluto's frozen crust, it's likely that they were produced within the last 500,000 years, or perhaps less recently. Pluto creates an age-old dilemma in this way. Polygonal shapes and features on the dwarf planet's surface indicate that it's a young and active geological system. The surface is only a few thousand years old despite the dwarf planet's 4.5 billion-year-old age overall. A thermal, convective overturning of the ice is most likely the cause of this action. How did Pluto form? Even though Pluto today is one of the coldest places in the universe, it might have had a violently hot start according to new discoveries by scientists. Before, astronomers thought Pluto's ancient subsurface sea slowly formed over millions of years as radioactive decay melted ice on the dwarf planet. However, new findings of scientists questioning that theory. A team of scientists combed through vast amounts of images of Pluto taken by the New Horizons spacecraft for clues as to the origin of the dwarf planet. This is possible thanks to the sculpted valleys and mountains on Pluto, which can reveal details about how the dwarf planet was formed. The same thing is obtainable on the Earth with its own mountains and valleys. After the analysis of the dwarf planet's bizarre surface features, the team created a series of computer models that investigated the different methods through which the planet could have formed. The scientists said if Pluto started cold and the ice melted internally, then Pluto would have contracted. There would be telltale signs such as compression fractures on its surface. However, if Pluto started hot, it should have expanded as the ocean froze, and there would be telltale signs of extension features on the surface. But the team only found evidence of extensional features, pointing to the fact that a short violent start could have given way to an early ocean. With this realization, the team then calculated what it would take for the dwarf planet to start off as a heated body. There are two ways Pluto could have generated the heat at the early stage. Energy from radioactive decay warmed the proto-dwarf planet, or it was bombarded by nearby material and the energy from these impacts would have spurred melting. They concluded the second scenario was more likely. If Pluto's formation took too long, the heat created by the gravitational energy of these impacts would have escaped into space. This shows that the formation of Pluto must have been a brisk affair. But of course, in the timeline of the universe, that brisk time could have been about 30,000 years. How did Pluto lose its standing as a planet? Pluto enjoyed this status for decades until the International Astronomical Union changed the definition of a planet by setting forth some basic descriptions that a planet must meet. Unfortunately, Pluto did not meet all of these new requirements, forcing geography textbooks to be rewritten all over the world. So what makes a planet a planet? According to the IAU, a planet must orbit around the Sun, must have sufficient mass to assume hydrostatic equilibrium or a nearly round shape, and must have cleared the neighborhood around its orbit. The problem was the last one. Pluto has not managed to clear its neighborhood of other objects or become gravitationally dominant. It has not been able to expel other bodies of a similar size to it. As a consolation, Pluto was given the title of a dwarf planet, and the number of planets dropped from 9 to 8. A recent photo analysis revealed a rough patch on Pluto that is unlike anything else on the small world or in our cosmic vicinity. This lumpy region is home to a smattering of unusually enormous ice volcanoes unlike anything else we've ever seen in the solar system. The location is southwest of the Sputnik Planitia ice sheet, covering 621 miles 1,000 kilometers of the ancient impact basin. It mostly consists of lumpy water ice and is covered in volcanic domes. Wright Mons and Piccard Mons are two of the largest. Piccard Mons is around 22,965 feet 7 kilometers high and 139 miles 225 kilometers wide, whereas Wright Mons is roughly 13,123 to 16,404 feet 4 to 5 kilometers tall and spans 93 miles 150 kilometers. The Mauna Loa volcano in Hawaii is one of the largest volcanoes on Earth, and Wright Mons is thought to be comparable in size. Some of the domes seen in the photos combine to form even larger mountains, but what may have caused them to exist? It all boils down to ice volcanoes. Ice volcanoes have been discovered in other parts of the solar system. They produce a new landscape by moving material from the subsurface to the surface. When the water reached the freezing temperatures of Pluto's surface, it swiftly turned to ice. Pluto's snow-covered mountains look like they belong on Earth, but they are in fact completely different from our own planet. It's hard to compare the appearance of these features to any other volcanoes in the solar system, be it icy or rocky. They started out as mountains, but there is no caldera at the top, and they are covered in big bumps. Can life in any form survive on Pluto? Due to the extreme conditions on Pluto, there is no chance of life on the surface. The temperature is simply too cold. Not only does water freeze solid at these temperatures, but other liquids and gases that are present on Pluto's surface, such as methane, nitrogen gas, and carbon monoxide, also freeze solid. These compounds have much lower freezing points than water, and so the chance of life surviving under these conditions is slim to nil. The pressure on Pluto is also between 1 million and 100,000 times less than Earth's atmospheric pressure. However, that life cannot exist on the surface of Pluto does not rule out the possibility of life being found inside the planet. What does the interior of Pluto look like? Scientists say that Pluto has a differentiated internal structure, with rocky material that is settled into a dense core surrounded by a mantle of ice. The diameter of the core is about 1,700 kilometers, whereas the ice layer is estimated to be 100 to 180 kilometers thick at the core mantle boundary. Even though Pluto is freezing on the surface, scientists say there might be a liquid ocean of water within Pluto. How? Well, the decay of radioactive elements would eventually heat the ices enough for the rock to separate from them. However, scientists predict the conditions on Pluto may change in the future, which will allow life to exist on the dwarf planet. But that will actually spell disaster for the Earth. It is true that Pluto for now is outside the habitable zone surrounding the Sun, but the Sun will eventually expand into a red giant, increasing the amount of energy it gives off for a period of several millions of years. Once the core hydrogen is exhausted, the Sun will expand into a subgiant phase and slowly double in size over maybe 500 million years. As it grows in size, the Sun will consume the inner planets, including our very own Earth. but the habitable zone will spread to the outer solar system. By that time, the Sun would have become so hot that the Earth will be hotter than Venus is today. The Sun will then expand more rapidly over another 500 million years until it is over 200 times larger than it is today and a couple of thousand times brighter. This then starts the red giant branch or RGB phase, which will last around 1 billion years. Within this period, the Sun will lose around 1/3 of its mass. Many objects in the Kuiper Belt will warm up significantly, and that will include Pluto. However, given the composition of these bodies and the relatively short window in which they will be warmer and wetter, it's not likely that life will evolve from scratch on Pluto. Most likely, we would have to transport it there from Earth, assuming humanity is still living, and seed Pluto and other surviving bodies with vegetation and terrestrial organisms. Meanwhile, you don't have to worry, these cataclysmic cosmic events are not scheduled to start until about 5.4 billion years from now. However, the JWST can help scientists look for signs of life on Pluto. This is a normally difficult task that would have required sending a probe to Pluto that may send back samples to Earth for analysis. Scientists have compiled about 5,000 exoplanets, with hundreds suspected of being able to host life. But the JWST can be trained on a dwarf planet like Pluto to study it. To detect life on a planet, astrobiologists study light that has interacted with the planet's surface or atmosphere. If there has been life on the planet, it would have transformed the atmosphere or surface. The light passing through the atmosphere may carry a clue or a biosignature. Take the Earth, for example. For the first half of its existence, our planet had an atmosphere devoid of oxygen, even though it had simple, single-celled life. So Earth's biosignature was very faint during this early era. Fast forward to 2.4 billion years ago, and a new family of algae evolved. The algae used photosynthesis, whose byproduct is free oxygen. This oxygen isn't chemically bonded to any other element. At this stage, Earth's oxygen-filled atmosphere began to generate a strong and easily detectable biosignature on light. One principle scientists bank on is that when light bounces off the surface of a material or passes through a gas, certain wavelengths are more likely to remain trapped in the gas or material's surface. This selective trapping of wavelengths of light is why objects are different colors. The specific composition of the material the light interacts with determines the pattern of missing light. Using this, astronomers can learn about the composition of a planet's atmosphere or surface by evaluating the specific color of light that comes from a planet. Astronomers can determine the presence of particular atmospheric gases associated with life because they produce very specific signatures in light. It could also pick out peculiar colors on the surface of a planet. On Earth, for instance, the chlorophyll and other pigments plants and algae use for photosynthesis capture specific wavelengths of light. These pigments produce characteristic colors that sensitive infrared cameras can detect. So if scientists see this color coming from the surface of a distant planet, it would potentially mean there is chlorophyll on the planet. Not just any telescope can analyze the light coming from a distant planet in this way. In fact, only the JWST can do so, and that is why there has been a lot of excitement surrounding it. And the great thing about the JWST is it has already demonstrated it is capable. For example, when it began science operations in July 2022, astronomers took a reading of the spectrum of the exoplanet WASP-96b. The analysis of the spectrum showed there were water and clouds on the exoplanet. But of course, WASP-96b could not have hosted life due to its size and temperature. In the coming months, the JWST will turn its attention to TRAPPIST-1e, a potentially habitable Earth-sized planet that is about 39 light-years from Earth. The JWST has also been used to study a planet in our solar system, Jupiter, and the results were stunning to say the least, which proves that studying Pluto will be a walk in the park for the Space Telescope. This was part of the setup process, and NASA released some of the demo photos. The space agency also used the photos to prove the JWST can focus on not-so-distant objects too. The level of detail was outstanding even though they were not processed. The first batch of photos showed Jupiter's cloud bands, the massive Great Red Spot Storm, and even some of its faint rings. Several moons are visible in the images as well, including Europa. The latest images show the massive planet and again with the Great Red Spot. They also show the rings. The images help scientists to understand the atmosphere, thermal structures and layers, and winds and auroras on the planet. Scientists only focused the JWST on Jupiter using the NIRCam for 11 minutes with the F212N filter that can detect hydrogen. Up next for imaging is Jupiter's moon Io. Pluto is known for its ice, but what happens to Pluto if it gets close enough to the Sun? If it did ever get close enough to the Sun, much of the surface ice would eventually thaw, and its atmospheric layers would be at their thinnest, lacking much of its carbon monoxide ice, but mostly retaining its nitrogen and a little bit of methane. At that point, scientists might consider Pluto to be in its most habitable form. Although we have no idea what to do about its low gravity, which is about 1/20th of the Earth's. Hence, its atmosphere appears much denser and higher than Earth's, and the further it strays away from the Sun, the denser it becomes as the atmosphere freezes until it phases out of view. When considered at its thinnest, scientists have surmised that it restricts the flow of fluids. One proof of this is provided by the New Horizons in an image of a frozen lake in the Tombau Regio. They also saw what looked like water channels. We join them in thinking about the possibility of the planet having an atmosphere 40 times denser than the red planet, talking about Mars, of course. There were also observations of certain cloud forms in the atmosphere. The clouds were formed at low altitudes with technically the same sizes, but the major components of these clouds are thought to include acetylene, ethane, and hydrogen cyanide. Did you also know that the dwarf planet spins back from east to west, which opposes everything that makes up the characteristics of the major planets in our solar system? There's a lot of information waiting to be discovered about the planet. NASA's New Horizons mission is the only mission dedicated to observing Pluto, its moons, and every other world that may exist beyond it in the Kuiper Belt. Not knowing much about the planet means we don't know if the probe will survive the harsh environment that awaits it beyond Pluto's orbit. The fact it already has 5 moons as satellites has not done much justice to easing fears that the spacecraft could collide with debris or undiscovered moons and eventually be crushed under their weight. For now, we expect it to show us more up-close images of Pluto as we anticipate a better understanding of what thrives on Pluto. For decades, scientists believed that Pluto's stony core lacked the internal energy necessary to stoke volcanoes. They believed that several eruptions would have been required to form the area. Additionally, the lack of impact craters in the area, which can be observed across Pluto's surface, shows that the ice volcanoes were active very recently and that Pluto's interior has more residual heat than expected, implying that our understanding of planetary systems is incomplete. As far as geological timescales go, the ice volcanoes may have been active as recently as 100 million or 200 million years ago. Observing Pluto's ice volcano would be an experience unlike anything you've ever seen before. On this dwarf planet, instead of erupting gases and molten rock, the cryovolcanoes on this dwarf planet expel massive amounts of ice, most likely frozen water. While flowing out of its volcanic vent onto Pluto's surface, the frozen material would most likely be a slushy mix of ice and water, or more like toothpaste. The explanation for this is that liquid water cannot last long on Pluto's surface due to its extreme temperature. In any event, the flow of material created the gigantic domes that we see today and the bumpy topography that can be observed across this region. The team working on New Horizons was only able to observe the region for about a day as it flew over this region, therefore they were unable to observe any present ice volcano activity. In theory, the ice volcanoes could still be active at this time. They could be like Earth's dormant volcanoes, which become active again after a period of inactivity.